Hello, boys and girls. We are going to continue our lessons on energy, and we are going to be learning about light and sound energy. We will be covering all the different properties of light, what reflection is, the colors of light, refraction, and then we'll jump into sound energy, and we'll also touch on how do your ears work. Before we begin, let's do a little bit of a review about what is energy. Energy is the ability or the force to do work. And we started off learning about heat energy. Heat energy is a form of energy in which our sense of touch can detect. And there are many different examples of heat energy. Heat energy can be produced in many different ways. We have conduction, the transfer of heat through touching. Convection, the transfer of heat through water or another liquid and gas. And radiation, which is energy that is spread by a heated surface, and the heat goes off in several different directions. With that being said, let's talk about what is light energy. So if heat energy, we can feel it, okay? Light energy is a form of energy in which our sense of sight can detect it. There's natural light, light that is made naturally by the sun, and artificial light, which is light originating from a man-made source. And this is light made by a battery or electricity. Another form is fire, where this would be considered man-made because we had to light the candle in order for the candle to give off light. Darkness is the term we use when there is an absence of light. That means there's no light shining. Now, as we go over these different examples of light and sound and heat energy, you are going to come across several examples where some things have more than one type of energy. So if we look at the sun and fire, they both have light energy and they both have heat energy. So if you were to say the sun has light energy, you would be correct, but you'd also be correct to say the sun has light and heat energy. And you're going to see several different examples where you're like, oh, well, that also has this type of energy, and you're correct. Let's go over the properties of light to learn more about what is light. When we talk about light, light travels in straight lines. Now, it can go in all directions from the source. So the source for this example would be the sun. It can go in all directions, but all the directions, the light travels in a straight line or a straight path. Light travels very fast, around 300,000 kilometers per second. At that speed, light can travel around the world 8 times in 1 second. That's how fast light travels. And because that's how fast light actually travels much faster than sound. For example, did you know that thunder and lightning actually start at the same time? But you will see the lightning first, and then you'll hear the thunder. Or if you're watching a race and they put the starting pistol in the air, you will see the flash and the smoke first, and then you will hear the bang. +2, did you know that light energy can cause things to look different? We have reflection, which is where light bounces off of a surface and produces an image. We also have refraction, which is when light travels through water and it makes it look like whatever's in the water is bent. And we also have a shadow. When light hits an object, but it can't go through it, it produces a shadow. We're going to take a look at each one of these examples, starting with reflection. Reflection is when light bounces off an object like a mirror or shiny materials. The mirror, or whatever it is, shiny material, will reflect the light at the same angle that the light strikes them. This works the same way as a ball bouncing from on a flat surface, like it's like boom, boom. So the way the light hits it, it reflects back. So reflection, when a mirror reflects lights, okay, so you're looking into a mirror, it will actually reverse the image. We see things because they reflect the light into our eyes. So here's the direction of the beam of light. Here's a flat piece of paper, and this is the direction of the reflection of the beam bouncing off. Okay, the beam of light bouncing off and into our eyes. That's how we see it. There are luminous and non-luminous objects. A luminous object is one that produces light, and a non-luminous object is one that reflects light. So here's examples of objects that produce light. Sun, a light, a lamp, a flashlight. Whereas our reflectors are going to be water, shiny objects, something that's metal, or a mirror. Now, with light, and because light travels in a straight line or straight path, if there's an object that is in the way of the path of the light, it is blocked. The light cannot shine through. So if the sun is here and the light paths are going here, it gets blocked by the tree and it produces a shadow. That means the light is touching all around here, but it can't pass through the tree. And so that's how shadows are made. Shadows are the places where the light is blocked. Now let's just do a little review here, okay? So remember, light travels in straight lines. Light travels much faster than sound. And we see things because they reflect the light into our eyes. And shadows are formed when light is blocked by an object. Now let's look a little bit more at that reflection, okay, and how mirrors actually work, all right? So if this is the mirror, okay, we have the ray of sun, okay? This is the angle in which the ray of sun, and it's reflected off into the opposite direction in the same way, okay? So we have it, and they just bounce right up, all right? So when we have that light gets reflected from a surface at the same angle, it hits it, okay? So if light was coming in this way, it's going to hit here and bounce off in the same way. Now, there's also clear versus diffuse reflection, all right? Smooth and shiny surfaces have a clear reflection. It's like boom, boom, all right? You can see, like, if you've ever taken a mirror and you catch the sunlight and you can kind of like point the light into another direction, you can see it. But there's also some rough or dull surfaces, and they diffuse the reflection. That means when it hits, it bounces off in different directions because it's not smooth and straight. When we use mirrors, okay, there's two different examples, okay? Think of it as if you looked in a periscope is like a binocular, okay, where you're looking in, but the mirror is shining up so that you can see different objects. Or did you know that car headlights are also, they're bent because they will reflect the light out in many different directions as it's hitting, so that way more things are being seen. That's how it goes from like your low beams to your high beams. Now, we're going to jump out of reflection and talk about refraction. So refraction's pretty cool, and you're going to be doing some experiments. You're going to be doing some experiments with reflection, but you're also going to be doing some experiments with refraction with things that you have around the house. So refraction is when the light moves from the air through the water. The light actually slows down when it goes through the water. When it slows down, the light tends to bend. And when that beam of light, the beam enters the water at an angle and the light bends. When the beam of light enters water straight on, okay, so if it was coming up and down, it would not bend. But when it's coming at an angle, it does. And so we can see that because we're looking at this cup from an angle, and it makes it look like the straw is bent into two parts. Now, if the light was directly above, we would see this straw normally, like it would just look like a straight line. But because the light is off to the side here, it makes it look like it is bent. And that's actually the light bending and making it like an illusion. And we see that with different objects too. Like if you were to put a ruler in the water and you're standing at a certain angle, it's going to look like it's bent. We also have prisms, and they're usually like a triangle. It's a cut glass. And when light enters from the side, it is bent, and we see a rainbow of color. So refraction is the bending of light when it moves from one kind of matter to another. So as the light goes through the air and into the water. When light moves from one material to another, it's going to change speed, and this causes the beam of light to bend. One experiment you can do is do a drawing and then put a cup of water in front of it, and you will see that it will refract. It'll bend those colors, making it appear much larger. You can also do the pencil and water, which we will be doing as an experiment. And another one is if you fill a glass of water and put your face right next to it, it's going to bend that image, and it's going to make you look like you have like a big eyeball, a big nose, a big mouth. It's pretty fun to try. And you can try this with all different sizes of glasses to see which one bends the light more to make more of an effect. Now, I mentioned color and I mentioned prisms. So light is considered a white light, okay? A white light is not a single color. When somebody says, oh, that's a white light, that means it's a made up mixture of the 7 colors of the rainbow. And so how that happens is that the light is split through a prism, okay? This is how rainbows are formed. Sunlight, when it goes through the water, remember it slows down and it bends, so that means that that beam of light splits up and it reflects the colors of a rainbow, which is pretty cool. And white light has all the colors of the rainbow in it. The color of an object is the color that reflects back for us to see, and all the other colors are absorbed. So if we're looking at this green shirt, when the white light hits it, the green reflects back to us and we see green. The same with blue, or we see the different parts of the flower. There are 7 colors of light that people can see. We have red, orange, yellow, green, blue, indigo, and violet. Another way that we remember it is Roy G. Biv. All right, if you can remember that, Roy G. Biv, you can remember all the colors of the rainbow in the order in which they appear. We have red, orange, yellow, green, blue, indigo, and violet. A prism is a solid object that bends light. All right, it refracts. As the white light enters the prism, its speed changes. Okay, and the change of speed causes the beam of light to bend. All the colors of the white light have different wavelengths, and they are bent at different angles so that all the colors separate. And you can see, here's the white light. The white light bends right in here and splits the different wavelengths, and that's why we see the colors red, orange, yellow, green, blue, indigo, and violet. Roy G. Biv. I remember I said water can act like a prism, okay? Sunlight comes in, it hits at different angles, and it's bouncing off, bending, and separating the colors, all right? And that's what happens through a single raindrop, okay? So when sunlight goes through a large storm, many different raindrops, you have a brighter rainbow. Now, white light can split up to make separate colors, and these colors can be added again together, all right? So we have the primary colors, which are red, blue, and green, and you can mix them by like adding blue and red, you're going to get a purple color. If you mix red and green, you're going to get like a yellow color. And the same here with green and blue. All right, so you can see all of these colors, but when you put them all together, you can see that adding all 3, the red, green, and blue, it's going to make white again because it's just going to keep kind of like watering it down. The color of an object appears depends on the color of the light it reflects. For example, a red book only reflects red light, so that's how we see that it's red. The same with purple pants. All right, we've got white light coming in and it's going to reflect, but it's going to reflect red, blue, and purple, but we see it as all purple. A white hat would reflect all 7 colors and we see it as white. Now, if we look at a colored object and we've got 2 different colors, it's going to be reflecting those 2 colors so that we see this as red and that as blue. Now, if we were to show red light coming in on a red shirt and blue pants, the red shirt would definitely look red, but the shorts are going to look black because it's only adding red in there. And the same thing if we showed a blue light on to the blue shorts, we would see the blue, but even though this is red, it's going to look black. It's pretty cool the way light works. Now, another thing that we're going to cover, okay, this is the last thing we're going to cover with light today, is absorption. So, when light hits an object, the object can absorb the light, okay? That's where it's absorbing all the colors that it's not. And it reflects the light or the color that it is, all right? And it makes it bounce off or it lets the light pass through. Remember, white light is all the colors reflected. Black is the absorption of all the colors. So, this is why if you wear a black shirt, let's say you wear a black shirt and black pants in the summertime, and the sun is out super bright, you are going to feel hot because it is absorbing all of the light and producing heat. And so you're going to feel that. You're going to feel much hotter than what it actually is because the black is taking in all the light and heat. Now, if you wear white clothes, okay, or light colored clothes, you're actually going to feel cooler because when the white light hits that light colored shirt or pants, it reflects it all off. And so you feel cooler. It doesn't absorb it and make you feel hotter. Kind of crazy, but that's how that works. So if we're looking at it, okay, we're looking at when the sunlight hits a color, some colors are absorbed into that color, but it reflects off the color that we see. So here comes this, the light hitting this red shirt. It absorbs the blue and the green, and it reflects off the red. We see red. When the sun or the light hits the pants, red and green components are absorbed, and it reflects off the blue. Right? It's a lot of different information, and we're going to be learning more about light energy and how light energy can change the way things look or appear. We're going to continue that topic in our next lesson.